In this video, we will discuss the problem probability of night. The problem says that we have been given a chessboard which is of size n cross m, and we have been given a knight which is initially standing at the position x comma y, and the knight can move exactly k steps, right? So it is allowed that the knight will move k steps, and in one step the problem says that knight has 8 options. So you know that in a chessboard, like in this case, it is saying that the knight can move k steps, but if the knight moves by one step, right? So if the knight moves by one step, so it has 8 options, right? It has 8 options. Why? Because if suppose that the knight is standing here, so it can go up and then towards this side, right? It can go here, or it can go up and then here, right? It can go down and then here. It can go down and then left. It can go right and then up. It can go right and then down. It can go left and then down. It can go left and up. So these are the 8 directions in which it can move. So basically, if I tell you using this example, so here you can see that if this is the grid that's been given to me, so it will move up and then here, then up and then left, then similarly right and down, and right and up, then down and right, down and left, then left and down, left and up. So these are the 8 different positions to which the knight can move, right? After this, you can observe that this will happen in one step, right? So if the knight takes one step, then these 8 options, these 8 positions are there to which the knight can move. And the problem says that ultimately the knight is allowed to move k steps. So if these are the possible set of positions if the knight takes k steps. If the knight takes one step, so if the knight is taking k steps, so in that case it can also fall out of the grid, right? Because suppose it is standing here, so if it take this kind of a step, so it will fall out of the grid. So what you have to tell is, you have to tell the probability, you have to find the probability that the knight remains inside the chessboard after taking these k steps, right? So suppose that the knight has taken k steps. In that case, you have to tell that what is the probability that the knight will still remain inside the chessboard, right? With the condition that that it can enter the board once it leaves, right? So this is what you have to tell. Now in this problem, how will you do this? So first of all, the first thing is that what are the actual coordinates. So let's say the white position that it is at, this white position is I comma j, right? Suppose that it is standing at I comma j. So let's try and identify the coordinates in the first step. So in the first step, it has these many directions. So if I talk about this position, so this position will be what? This position is nothing but I minus 2, because I am moving 2 grids upwards, right? I minus 2 comma j plus 1. If I talk about this position, this x, so in that case the position is nothing but I minus 1, because I am moving one row up, and the j column will be j plus 2, right? Because I am moving 2 columns towards the right side. If I talk about this column, this particular row and column, so in this case it will be I plus 1, because I am moving one row down, and j plus 2, right? You can see. Now if I talk about this x, so this x is this position will be what? This position will be nothing but I plus 2, because I'm moving 2 rows downside, and then j plus 1, right? J plus 1. If I talk about this position, so it will be what? I plus 2, because I'm moving 2 rows down, and then j minus 1, because I'm moving one column towards the left. Now if I talk about this, so I will be what? I plus 1, and then the position of j will be nothing but j minus 2, because I'm moving 2 steps towards the left side. Okay. If I talk about this position, so this position will be what? This position will be nothing but this position will be I minus 1 comma j minus 2, because I'm moving one row upwards and I'm moving 2 column backwards, right? If I talk about this position, so this position will be nothing but what? I minus 2 comma j minus 1, because I'm moving 2 rows up and one column back, right? So these will be the positions. So how, like, will you write all these positions? No. Basically you can see that the combination is there, right? So you can see that for the first coordinate, for first coordinate minus 2 and minus 1, right? So you can say that if I want to change I, so it will be changed by x will be changed by minus 2, y will be changed by minus 1, right? Similarly, if you talk about this one, so here you can see that plus 1 comma 2, right? So these are the combinations that I need to make. So I have already made this vector, if you will see. So I've made this vector because as you saw, like I had minus 1 with minus 2, right? I had 1 with 2, because you can see here, if I show you here in this diagram, so you can see that 1 comma 2 was there, right? You can see here plus 1 and plus 2. So with respect to a particular position I comma j, I can move to one row down and two columns towards the right side. Okay, this way. Then plus 2 and 1. So you can see this pair also I have made according to the x and the y indexes. That is plus 2 and then 1. I have also made this. So this is how like you can see plus 2 and 1. This is how I have made it to traverse one by one, because I will not be writing all these 8 conditions. I can simply say that I can store all these combinations in a particular vector and then I can move to all the positions. Now the thing is how to calculate the probability. Once you are done with this part, so the thing is that how actually to do this. So you can say that, let's suppose that you were standing at I comma j, right? You were standing at the cell I comma j. So what you could do, you could move to 8 different directions, right? You can move to this, you can move to this cell, you can move to this cell. I'm not naming the cells again, right? But you can understand, I've already told you earlier. So 1 2 3 4 5 6, let's say 7 and then 8. So 1 2 3 4 5 6 7 and 8. So you can see 8 directions are there. So if I say that here standing for me standing here, the probability is 1, then I can be present at 8 different directions, right? And I'll be choosing one of them, right? Suppose that I choose one of them. So I can say that for the first cell I have 1 by 8 probability. For the second cell I have 1 by 8 probability. For the next cell I have probability 1 by 8. Next cell I have the probability 1 by 8. Next cell I have the probability 1 by 8. And similarly for all the 8 cells I have the probability as 1 by 8, because 1 by 8 plus 1 by 8 up till 8 times will give me nothing but 1. So the total probability will come out to be 1, right? So this will be the condition. Now similarly for this cell, suppose I choose the suppose I pick up this cell. So for this cell also I'll have 8 options, right? Suppose for this cell I'll have 8 options again. So 1 2 3 4, then 5, then 6, and then 7, and then 8. So you can see that for this cell also I'll have 8 options. So now what will be the probability? Because this cell, if the parent cell, if the parent cell had the probability 1, then its children cell had the probability 1 by 8. So if the parent cell, if this cell is having the probability as 1 by 8, so its children will have the probability as 1 by 8 into 1 by 8, right? Because every time you can see that there are 8 different cells through which I can move. So that's why if the parent cell is having the probability as 1 by 8, so I'll have the probability 1 by 8 into 1 by 8, that is 1 by 64. And that is actually true, because if you see in the upper part, so the probability of reaching this cell from the topmost starting cell in this is nothing but 1 by 64, right? Because for every other cell there will be 8 options. For this cell also there will be 8 options, right? For this cell also there will be 8 options. For this cell also there will be 8 options, right? So that's why the probability of reaching this particular cell, this blue cell, will be nothing but 1 by 64, right? So that's what I have to do. Now when will I add the probabilities for a particular cell, right? Suppose that instead of moving this much, suppose that I just took one step and I have to calculate the probability, that how much is the probability. So I can definitely say that suppose that there are some cells, suppose that this cell, this cell, this cell, and this cell, suppose these 4 cells are out of suppose that these 4 cells are something that go out of bound, right? They are outside the chessboard. So I can say that these 4 cells are remaining. So I'll say that 1 by 8 plus 1 by 8 plus 1 by 8 plus 1 by 8 is the probability of me remaining, because if I go out of the cell, so the probability will become 0, and if I'm inside, so I'll add their probability, right, 1 by 1. And that's how I can get the final probability for this level, right? But I need to find it overall, right? So I'll have a probability variable that will help me to calculate for each and every level one by one, right? So this is something that I will be doing, right? And after this part is done, so I'll simply print the answer. And what are the 3 parameters that are changing? I can see that my x variable, x coordinate is changing, y coordinate is changing. Apart from this, the number of steps, right? So you can say k, the number of steps is changing, right? Because first step, then second step, then third step, then fourth step. So there will be a lot of steps here that will be included. So this is also something that I need to keep in mind, right? Let us try and quickly implement this code so that we can learn more about it. So as you know that I have made this dx and dy for all the 8 directions to which I can move, right? I can say that what I will be first of all doing is I'll declare a dp variable, right? I'll say that double dp. So I'll declare a dp variable which will be of 3 dimensions. So n n and n, because I can say that x y and k will be the changing parameters. So that's why I need 3 parameters here. And then what I can say is that after this dp is declared for the double, I will say that I need to simply iterate in this DP, and I need to mark all the initial values, initial probabilities as 1, right? Because if I've taken, suppose that I've taken no step, right? As I mentioned, if this is like this 1 by 8 is the probability after taking the first step, right? After taking the first step, the probability for every cell will be 1 by 8. But suppose that if I have not taken any step, if I have taken 0 steps, so I can say that if I have taken 0 steps, then the probability will be 1, right? So that's what I'll be doing. So first of all, I'll be iterating through all the cells, and I'll be saying that suppose that I starts from 0, I is lesser than n, and I plus plus, right? After this part, I'll say that I'll run a loop for j. So for int j starts from 0, right? J starts from 0 and j is lesser than n, then j plus plus, right? So what I will say here is, I'll say that here I'll say that if for every cell I comma j, I'll mark the I comma j, right? For every cell I comma j, I'll say that if the number of steps are 0, in that case I'll mark the probability as 1, because if I've not taken any steps, then the probability of that cell will be 1, right? Right after this part, what I will do is I'll run for the steps. So I'll say that I need to run for each step. So I need to say that int, let's say step is let's say s is equal to steps, so step 1, then steps will be lesser than steps, right? That the given number of steps is steps. Then I will do s plus plus here, and like I'll be running for each step, right? And I'll start iterating. So I'll say that for int x starts from 0 and x is lesser than n, capital L, and then x plus plus. So one by one I'll be changing my x coordinate and y coordinate. So I'll be running and then I'll say that int y starts from, because I've already been given the starting x cell and the starting y cell here in this part, so I'll be using that in this loop. So I'll say that int x is equal to 0, y is equal to 0, y is lesser than n, right? Y is lesser than capital N, and then y plus plus, right? After this part is done, so what I will do is, after this part is done, so I will say that now I need to say that first of all I'll say that initially the probability will be 0, right? And I'll keep on adding the probability one by one. So as I'll say that double probability is equal to 0. I'll initially mark the probability as 0 and I'll keep on iterating. So I'll say that how many positions I can iterate through. So I can say that I can iterate overall through how many positions. So I can iterate through a total of nothing but how many directions. I can iterate through 8 directions, so I have made a vector for that. So I can say that int let's say int I starts from 0 and I is lesser than 8, I is lesser than 8, and then I plus plus. And then what I will be doing is I will say that now I need to calculate my new x. So int new x will be nothing but the x value that has been given to me, the initial x coordinate that I am at, right? Initial x coordinate that I am at, right? And then x plus what, dx of I, right? X plus dx of I, and int ny is equal to nothing but y plus dy of I, right? So I'm basically making a new x and the new y, right? And now I need to check that if this new x and new y that I am at, if it is inside. So I'll make a function for myself. I'll say that I'll make a function inside which will tell me that whether or not in this grid of n cross n size, in this chessboard of n cross n size, whether or not this new x and new y coordinate is lying inside it or not. If it is lying inside it, then it will return a true, and if it returns a true, then I'll add the probability, overall probability. I'll add the probability for this cell in the overall probability for this level, right? So I'll say that probability plus is equal to nothing but dp of new x, right? Dp of new x, new y, and the number of steps that I have taken previously, right? In divided by what? Divided by 8.0, right? Divided by 8.0, because every time I said that the probability will keep on dividing by 8, right? For the first level, the probability will be 1 by 8, then the probability will be 1 by 64, then the probability will be 1 by 64 into 1 by 8, right? So it will keep on decrementing for every step. It will keep on decrementing by 1 by 8, right? So that's why I have taken this. After this part is done, so I also need to implement the inside function, right? So in the inside function, what will I do? So in the inside function, I need to declare this thing, that in the inside function I'll say that I need to have a bool inside function that will tell me that whether or not this x comma y cell is inside or not. So I'll say that int n and comma int x comma int y, indicating the cells, the x and the y coordinates, right? So I'll say that what I need to do is I need to say that if it happens, right, if it happens that x is greater equal to 0, right, x is greater equal to 0, and it happens that x is lesser than n, right, So if x is in control and it happens that y is greater or equal to 0 and y is lesser than n, in that case it is valid. In that case I'll say that okay, I need to return what? I need to return true. That means that this particular state will be fine. Otherwise I need to return a false, right? Otherwise I will return false, indicating that that cell is outside the chessboard, right? That particular cell is outside the chessboard. Once I have done these calculations, so what I will do, I'll simply say that now I'll store like once the computations are done for this particular level, so once this for loop is done, right? So after this part, so I will say that now I need to store this answer, right? So I need to say that since I'm storing this particular answer here, so after this, if for loop is over, so I'll say that now I need to store it. So I'll say that dp of what? Dp of x, the x cell, the y, xy is equal to nothing but dp of xy, and the number of steps as s is equal to nothing but the probability that I have calculated up till now, right? After this part is done, so I will say that now the probability will get stored one by one, and for which cell I need to return the probability. I need to return the probability for which cell? For the start x, right? For the start x and the start y, right? And the number of steps. So I need to say that in the end I'll return the probability for start x, right? Start underscore x, right? And then start underscore y, right? Because initially I was thinking that I'll be starting from every cell, so I calculate the probability this way. And suppose that if I start from this cell, start x, start y, and start and the number of steps, so I will know this probability because it will already be stored, right? So now let us try and compile this code to see if there is any compilation issue. So you can see that we are getting the expected output as 0.125. Let us try and submit this code. So you can see that our solution was able to pass all the test cases, and in this problem, since we use 3 loops one inside the other, so the overall time complexity for this approach is going to be order of n cube, and the space complexity is also going to be n cube because we took a 3D vector. Thank you for watching this video.